do the extraction, if I think if the number of factors are how can we determine the fixed number of factors? I know we can do some reduction or dropping off, but for the first steps, we just allow the SPSS do it? Or?
Yes. First time you allow SPSS, because SPSS has got no theory. The program doesn't have any theory to be backed up. So it's just use the data, and it will see which item going to which one. And it will do mechanically. But you are a researcher. You're a human being, person, and you may have read in the literature regarding your research area. So you must have some ideas. So even if the SPSS tell you, okay, your data is giving me, after reduction, give me 4 factor, but your readings in the literature, articles, whatever, concerning your area of research, that would have given you some idea that it's only 3 factors or only 2 factors, something like that. If you know that, then that is an indication that you don't need 4 factors. You may have to go to the 2 factors, because that's what the literature is supporting. Don't rely too much on the data, because data comes from your subjects, your respondents. They may not have answered you well. They may not have given you the real expression. But the theory which is coming from, or theory or the literature, coming from some valid researchers, reliable, valid researchers. So you have to trust them more than the SPSS working. Okay, so that's why I say, even if it comes out with 4 or 5, it doesn't mean you must use all of them. Use your knowledge, use your literature understanding, and then you decide whether you need that many or not, whether you really have that many factors. Okay, I was giving you an example. Let's say your SPSS gives you 4, but if your research tells you, your research findings, literature findings tells you there are only 3 factors, then you bring down the number to 3. That means you decide now 3, even though your SPSS says there are 4, because SPSS is using your data to create the number of factors, whereas you are using the literature, which is knowledge that has been validated, that has been reliable. So you are right. You are better than your SPSS. First time, put into the SPSS, see how many it gives. Then you come to a conclusion. If it gives exactly the same number as you know, because your literature says there are only 2, and that one also gives 2, very nice, because both of you are matching each other. But if that one gives 4, you know there are only 2, then what you can do is you look at the 4 first, how they are distributed. If too much of cross loadings and all that, then better don't use that. You fall back to your 2 factor. Instruct the SPSS to use 2 factor and redo the extraction. So this time maybe it will extract for you in a better manner, just based on 2 factors. Maybe you can get it better results this time. Okay, but don't forget, you are a human being, you are a researcher, you have more authority in deciding the number of factors based on your knowledge with regards to your literature research. Okay, have I answered you?
Should the when we check the total variance explain?
Yes. That means there are other factors. You see, if the total variance doesn't reach 100, normally it won't reach, because there are so many other factors that will contribute. We may not know. You see, we cannot guess all the factors. Okay, let me ask you one question.
Okay.
Let's say you know of somebody studying in a school, maybe a secondary school student. He's scoring some high marks in his exams. What are the factors that contribute for his high marks? What are the factors? You may say teacher, you may say the school, you may say the parents, you may say the siblings, the brothers, you may say the peers. You can bring in many factors, but still your variance, total variance may not equal 100. That means there are still unexplained, unexplored factors that contribute to his success. So there is no way we can get 100%, you know. It's not easy. So if you get more than 50, you must be happy. That's why every time I do, I check the cumulative value after the two-factor extraction. If it is above 50, I'm satisfied. Because for my model, that's a good figure. Because I'm not giving a model that is comprehensive. I'm only telling you, okay, this pedagogy is dependent on this. There could be other things that affect the pedagogy, which I may not know. I may not know. So always believe that you cannot get 100%. Variance, total variance cannot be 100%. That's impossible because you can't figure out all the factors that affect. We may get some factors, but not all of them. That's why I gave you an example. What caused the student to be very successful? Is it parents? Is it teachers? Is it he himself? Is it he himself? His friends, his brothers, sisters, or the house and the room, the environment he's studying? What really? The school he's studying in, which exactly contribute? All would have contributed. All these factors that I'm telling you, the school, the room where he studies, the kind of food he's taking, all this have small contribution. So all the factors, if you can gather, meaning that you don't miss any factor, you have collected all the factors, then perhaps you may reach almost 100 variance. Okay, that means you can explain the variance, the change in the success, using all the factors you have. You can explain at least 90%, 95%, provided you have answers for all these factors. Normally, we don't have answers that that will tell you, oh, this many factors, nothing more. We cannot say that. We cannot say that. It could be factors, hidden factors, latent factors, unobserved factors that are contributing, but we don't realize, we don't actually know that. Unknowingly, it's affecting and doing things like that. So that is research, that's reality. You see? Reality is, they are like that. They are existing, you don't know. Okay, huh? So total variance, don't expect to be 100. Huh? Anything more than 50, you'll be happy. If you get 60, 70, that means you are almost there with the vectors. That means still you lose some factors you don't have, but at least you have come to 80%. But for me, a research model is good, fit, if it can give you more than 50%. Okay. Okay, let me go into the slide I was telling you. I'm going to show you the slide. Where is the slide? Okay. Oh, it's not open yet, is it? Wait, let me see. Where is the slide? Lecture 7. I thought I just opened it. Okay, wait, 7A. It's in 7A. I know. Okay. Can you see my slide? Can you see my PowerPoint? Not yet. Class, can you see my PowerPoint?
No.
Yeah, okay.
Yes.
Okay. I'm going to give you a general guideline for EFA. EFA is exploratory factor analysis. That means it's a factor analysis at the initial level. Do I do or not? If I'm a researcher, I'm using a questionnaire. Must I do a factor analysis or not? That would be a big question for me. Because there are some people say no need to do FA, factor analysis, especially the EFA. They say there's one more factor analysis which is confirmatory. I think I don't want to do EFA. I want to go straight into the confirmatory factor analysis. But then you must look at the situation or the setting where you are going to use the questionnaire. Let me show you one paragraph here. Read the paragraph and then I'll talk to you. Read this paragraph and then I'll talk to you. When you translate an existing instrument that has been tested before for its validity and reliability, in order to use it in another country, a different language, this instrument automatically becomes new. So you need to do EFA. Is it quite clear now, this statement? You take your instrument from another country, English originally, you translate it, you bring it over to your country, you go to your province, and then you are using. Is the instrument new? Yes, it is new. Why it is new? Because this time your setting is new. The language is different.
Yeah.
So it is considered new, and therefore you need to do an EFE. Look at the second paragraph. When you use an existing instrument that has been tested before, because you are not the first person to test, it has been tested, maybe existing, already existing, validated, reliability also confirmed. You are using it in the same country somehow, same language somehow, but in another sector or another setting. The instrument that you take was used in a town area, urban area, but now you are using it in a rural area. It is considered new. Therefore, you have to use EFA. Okay, you understand?
Yes.
So some people ask me, some people argue with me. They say, no, I'm not doing anything. I just collected my instrument. I only change one word there, one word here. The moment you temper, the moment you touch and change its originality, it is considered new. Therefore, you need an EFA.
Yes.
So unless, you see, so many conditions. I think you were quite observant in the conditions that I put in here. Another country, definitely EFA. Another language, definitely an EFA. Same country, same language, but a different setting, you need an EFA. You see? Another country, definitely you need an EFA. You take something from America, you must do an EFA. You take something from your own fellow, China researcher, but he was in Beijing and you are doing it somewhere in Shanghai, different area, different environment, you need an EFA because it's new. For your case, it's new setting. So this basically covers the question, answers the question, must I do an EFA? So you ask yourself whether the instrument you're holding, same thing goes to Juliet also. Juliet, you were asking?
Yeah, I know.
So if you had done some translation, you need. If you have changed some words, you have reduced from 10 to 12 or 10 to 5, 10 to 6, you have to do. Okay?
Must do the in the pilot study.
Yes. Before pilot study.
Pilot study, how many samples is enough? 13? 30? Okay.
No, 30 is too little.
Too little?
You know
total participants is just only 120.
Oh, total. Your population is only 100.
Yes, because my research design is big of the quantitative method. The quantitative.
Why only 100? Why can't you get more than that?
Because I have just only used the 3 kindergartens. The 3 kindergartens are total just only.
Where are you doing? In Malaysia?
No, China.
China. You are very sure your population is only 100?
Because I used the different 3 instruments,
okay.
Questionnaire and interview and the classroom observation.
Okay, what is your method? Your method is what? Mixed method.
Yes, mixed method.
Okay, which one? Mixed method, which one? Explanatory. Quantity first, is it?
Quality.
Quality first, then quantity.
Yes.
And then you have only 100 people. Okay. You see, I can suggest you that you cannot use SPSS because it's too little. You may have to use Smart PLS. Okay. That's an option. That's an option. Because when you cannot have 100, it's not enough. The population is enough. This is where the Smart PLS became much popular, because when there are conditions like what you are facing, you want to get more, but you cannot get. Okay, you want to get, you cannot get. This is called limitation. Limitation is such, you cannot go beyond 100 for your sample. The harder techniques, the MOS, the SEM, the normal CB, SEM, using MOS and all, cannot use. Even SPSS you will struggle because your number is not enough, 100. So your only choice is Smart PLS. If you go to Smart PLS, it will help you. Okay, it will help. But you definitely need to do an EFA because you are changing things, you are adding, whatever you do, you temper. The moment you temper, you touch only, it becomes new. Okay, remember, the moment you bring an instrument, however good the instrument elsewhere, let's say you get one from the best expert in student learning. I take the questionnaire and I want to use, but this questionnaire was from America and was tested there for many, many times, 1,000 over times it has been tested. So I bring it over to my country, Malaysia, and then I want to change it to Bahasa Malaysia. Finish. The moment you change only, you have to do EFA. Or if I see, oh, this one too many questions, I don't want so many items. I want to reduce them. Instead of 10, I want to make it 8 because my students cannot do so many answers, cannot give. The moment you decide like that, it becomes new. New means EFA is a must. Okay, so this is how we decide now whether you have to do an EFA or not. So this slide will be useful to you. It's in my notes, it's in my lecture notes, so you can use it. So if someone asks you whether you need to do or not, this is the answer. Okay, I think I want to start with my regression now. If you are ready for regression, okay. This is okay. Here, this is what we are going to do. The things that we are going to do next until 4 o'clock. Let's hope we can finish by 4 o'clock. 2:30 now, exactly 2:30. Let's hope we can finish. It looks a lot, but then when I go and show you the things, it may be faster. Okay, EFA reliability, I've done with you just now. So I'm going into the second one, linear regression. What is regression? Regression is like a relationship. It's a relationship, but then it identifies whether the IVs can influence the DVs. You see, if there is an influence, they want to know how much is the influence, how much. It's like a predictive relationship, whether the IV can predict or not, whether max mark can predict the overall result or not. What do you call? Can physical fitness influence the physical body or not of the person? This kind of prediction. That means when IV influence or predict the DV or not. Okay, that kind of relationship is linear, multiple, and all this relationship. In fact, all are from one family, regression family. But we are going to see one by one. What is linear, what is multiple, what is stepwise, what is hierarchical. Okay, we are going to see one by one. And let's see the first one is, I'm going to show you, is what we saw just now. Assumptions for multi. Did I show you this? Not yet, huh? Did I show you all this? Class? Did I show you this slide?
Yeah.
No.
No, okay, very good. You see, every time when we want to do some tests, some techniques, some analysis, you have to remember that there are some assumptions behind the analysis. If you want to do t-test, ANOVA, there is some assumption. What is the assumption? The distribution must be normal and the measurement must be interval. See, these are assumptions. So likewise, if you are interested in doing multiple regression analysis, multiple regression techniques, there are some assumptions. What is the first assumption? Sorry, what is the first assumption? First assumption is that all the measurements must be interval. The DV. You must know how to identify DV and IV. I'm using short form, IV, DV. IV stands for independent variable. DV stands for dependent variable. And when we draw a diagram, a concept, we always put the DV on our right, we put the IV on our left. So the flow is from left to right, okay? Not from top down. We don't use top down. We don't put IV on top, DV down. No, that is not the style. You saw earlier in my Smart PLS, it also from left to right. See, that one also will do from left to right because the arrows will flow that way. Okay, what are the basic conditions for assumptions in the multiple regression? The first thing is that the DV, the dependent variable distribution, must be normal. Must be normal. That means you need to do a test for normality. Then the DV must be measured using interval scale. At least interval ratio is even better, but interval, at least interval. Then second one is that you look at the correlation matrix, you look for the relationship between the IV and DV. The IV that you are putting in the model, must be related to the DV. It cannot be no relation. It must be related, but the relationship must be moderate. It must be greater, the R, the correlation coefficient R must be greater than 0.3, but must be less than 0.7. Why? Because when the correlation is more than 0.7, we use the term collinearity. Collinear means they are almost the same. Collinear. Two IVs, when they have a correlation of R more than 0.7, they are like twins, you know, they're like twins. They share many properties the same way. So we don't need twins in our study. If got twins, pull one of them away. Just use one only. Okay? So don't allow twins here. Huh? Twins means very much same. So how do we find? We look at the R value between the two. If the R is more than 0.7, we don't want. We have to push one fella out. Any one we push out. Okay, so these are the two basic conditions. The IV and the DV must be related, but it must be a moderate relationship, where the R is between 0.3 to 0.7. Secondly, among the IV, don't bring in DV, among the IV, they must be related, but cannot be very strongly related. That means the R value among them cannot be more than 0.7. So 7 is the mark for high. 3 is the mark for the low. So they should fall between 0.3 and 0.7. The next one is that the sample size. The sample size that we are using, there is a rule of thumb. Okay, it's not a strict rule, but general rule. That's why we call it the rule of thumb. Okay, rule of thumb. It says that you must have a sample size 20 times the number of IV. So let's say I'm studying pedagogy. I have IVs personality. I have subject knowledge. I have student knowledge. I have context knowledge. I have self knowledge. So let's say I have 5 IVs. So how many must be my sample size? What is my sample size? I have 5 IVs.
100.
100. Beautiful. 5 times 20. So if I have 4 IVs, then 4 times 20, 80. That's a minimum, you know. Anything more than that, very good, acceptable. But don't go beyond that. Don't go beneath that, below that. So this is a rule of thumb. If you are using 4 IVs, 4 times 20, 80. If you are using 10 IVs, 10 times 20, 200. It goes like that. You can't have a lot of IVs, but the sample size is so small. I don't know Juliet's IVs. Okay, so you have to be careful. If your sample size is very small, cannot accommodate, then I don't know how. Okay, but if you go to a smart PLS, you are safe. Because smart PLS doesn't care, doesn't bother about the distribution, doesn't care for the sample size. Any sample size it can use. Any non-normal distribution, skewed also it can use. So that's where the advantage for the smart PLS is. Okay. Okay. So these are the basic assumptions for multiple regression. Basic assumptions. Huh? Okay. I'm going to show you the first one of the family, linear. What is linear? Linear means straight line. Okay, linear, straight, linear, straight. So it deals with straight line graphs. So when I say regression, we will have a DV, which is our Y, and then we have an IV, which is our X value. So if you have done mathematics, especially the coordinate geometry, then you have y equals to 2x plus 3, y equals to 5x, y equals to 10x plus 33, all these equations, they all mean linear equations. So they all represent linear regression. Okay, I'm going to show you what is linear regression. When you have one IV which is acting on one dV, then it is called linear, something like this. 1 dV SAT scores. SAT stands for Scholastic Aptitude Test. So the score in SAT is our dV, dependent variable. The IV is the college marks. So we use the college mark to predict the Scholastic Aptitude Test, which will come later. Okay, so college marks comes now, or maybe is already with you. Now you want to predict who among your students can pass the SAT score. So you can check the college mark and then you can do your prediction. So if 1 to 1, like what is you see on the screen, 1 IV, 1 dV, and 1 only arrow, then this is called linear regression. Okay, linear means just 1 only. 1 dV, that's linear regression. But in reality, we don't normally get the 1 to 1. We will have more than 1. But never mind, we just see this first. Okay. And in terms of those who are keen and interested in the equation, you can see this same thing. I put it in the equation form like that. Y equals to mx plus c. So the m is the value that can change, that can predict. If m is bigger, then your prediction is better. Okay. If m is smaller, the prediction is not so good. Okay. So this is mathematical equation. Now, I'm not going to teach mathematics to you. If you want, you go and join some statistics class, then they will go through all the details of the theory behind this regressions. Okay. What sort of a question can be recognized as linear regression? And what sort of an analysis which will follow? Okay, look at the question now. I'm showing you one question. How well the college marks as one variable is able to predict SAT score. That's what you saw just now in the conceptual framework. If I turn that conceptual framework into question, this will be my question. How well means how much, to what extent. You see, you can phrase your question anyhow. You can ask to what extent college marks can predict SAT score, how well the college mark can predict this. However, but basically what you are asking is, can the college mark predict the SAT score now? Okay, so there's only one IV and one DV. So the method that we are going to use is linear regression. Okay, so identify the question from the question. This could be a research question. So you look, you read, understand, pick up your variables, which is IV, which is DV, and then you determine what sort of regression this is. So this is called linear because it has only one IV, one DV. Okay, let's do it. Means I'm going to show you something regarding that. Okay, so the same. You see, I'm trying to use the same. What shall I say? Same data, so that you need not worry about new data. When I bring in new data, I have a lot of data. If you look at my file, if I show you my file, AQRM file, okay, or maybe the lecture 7 file. You see, can you see or not? How many data are there? So many I have. You see here, these are SPSS symbol. So I can show you that 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't see that? You don't see, is it?
Yes, I just
Sorry. Don't worry. I'm showing you now. Okay, can you see now?
Yeah, the field list. Data
Can you
list.
see this? Lecture
Yeah,
7.
Yeah.
Okay. Okay, look at the number of data that I'm having here. I have 1, 2, 3, 4, 5, 6, not 6, 5, and then come down 6, 7, 8, 9, see, 10, 11, 12, 13, 14 data files, but I don't want to open all. You'll be confused because every time you see different names, different variables, you cannot focus. Okay, so I'm using the same data file. Huh? So bear with me because I want some clarity there. So I'm using the same D file, the personality, the pedagogy, the self-knowledge, context knowledge, subject knowledge, student knowledge. I'm using the same one. Okay, so since I'm going to show you linear regression, that means I use one DV, which is my pedagogy, and I'm going to use one IB only. It could be anything. It could be personality, or I can take the subject knowledge, or I can take the student knowledge, or context knowledge, or self-knowledge. I can take any of that. So I'm going to show you now how to do a regression. So you see here, this is the data. Go to analyze. Come down to regression. Where is regression? Don't go to the
Excuse
correlate.
me, doctor.
Huh? Come again?
Yes, we don't count your Swiss. It's just only the data list.
Okay, wait. Yeah, it's still the data list. I'm still with the data list. Okay.
Yeah.
Okay, now only I'm
it's
doing
not okay. Yes.
Okay, now only I'm doing, you say analyze. Okay, analyze, and then you come down here, regression. Okay, regression. Remember, analyze, regression, and then over to the right, linear. Press. So you get this table, you get this window, dialog box, whatever. So DV you put in the top corner here, top here, dependent. You see, dependent, independent. So what is my DV? My DV, I'm going to put pedagogy 1. Okay. Then my IV, since it's linear, I can only put 1. So let me put the personality 1. Okay, that's my IV. I have so many IV, personality 1, personality 2, subject, context, student, self, so many. But I don't want to use all. I just do these 2. I'm going to check now on this buttons here on the right. The statistics that I want to see is model fit, R squared, descriptive, part and partial, collinearity, and that's it. Case-wise diagnosis, maybe not necessary, but it doesn't matter. You can put it. Then go to the plots, no need, save, no need, options, exclude cases, pairwise, sorry, exclude cases pairwise. Okay. And then style, nothing, bootstrap. I just go back and redo for you. First, the statistics, you go to the statistics, make sure all the right side here are clicked. This will come automatically. You don't have to click. The moment you open only, it will be clicked. So click all this side, the R squared I want, the descriptive I want, the part and partial I want, the collinearity I want. This side I want to say that you, the case-wise diagnostic, even though I may not use it, but I'm just keeping it. Then down here plots, I'm not going to plot any graph. I'm not interested in graphs here. If you need, then you can plug here and then you put x-axis as your predictor. Okay, sorry, yeah. X will be your predictor. This one will go here. Then the residual will go here. If you are interested, but like I'm not interested. Okay. Then save, nothing much to save. You don't save anything. Just leave them as they are. Options, just say exclude cases pairwise. So this all apply when there is a missing value in the data. Supposing my data is not a clean data, there are some missing value, and these instructions will help SPSS. So it will immediately exclude data that doesn't have both the values. Maybe somebody, they have some value for the pedagogy, maybe no value for the personality. So when they don't have a complete pair, what SPSS will do is, according to my instruction, it will delete that case. That's what I say, exclude cases pairwise. That's the meaning of it. But if my data is clean, this one don't apply at all. Okay, it won't apply at all. Okay, that's all. I'm going for okay now, run. Done already, yeah? Go for the output. You see, can you see the word regression? This is the first table or first output for now. So you don't see anything else. It's only the regression table. So this is the beginning. Okay, the first one is for you to check pedagogy, the mean value of pedagogy, standard deviation, how many cases? 90 cases. Pearson, 90 cases, mean value, standard. And then over here, this is the correlation. Remember, I told you that assumptions for multiple linear or the regression family as a whole, the IV and the DB must be correlated more than 0.3. So where is the DV? DV is the pedagogy. Where is the IV? IV is a Pearson one. Okay. Okay. So we look at this one. You see, this almost crossing the boundary. 706. I want it to be less than 700, but slightly okay lah. Okay, slightly okay. Then look at nothing else to look, because the second assumption is when you have more than one IV. Now we are doing linear. There's only one IV, one DV. So just check whether this part is okay or not. So now for me it's okay. Then you look down here. See the model variables entered or removed into the model. So the model, the first model, there's only one model because one IV only going into the model. So it's all done. Okay, method is enter. Okay, and then this is the model summary. Normally what we do, we will go and look at this side, the right side, significant. Is the model significant or not? Is it okay for me to continue interpreting? Is it okay for me to continue down for more interpretation? You check here. If it is significant, then you go ahead. If not significant, no point going down. Okay, no point, because they are not related. They are not related. They don't predict anything. That's the meaning. Okay, so look at this. Significant or not? Yes. Then we can go down. But before that, come back here. Look at the adjusted R-square. You see, you will see two R-square. One is a pure R-square. Another is an adjusted R-square. What is the difference? The difference is in the sample. When the sample size is very big, both the values are almost same. When the sample size is not big, then it's better you go to the adjusted R-square, because this is a more conservative reading, meaning that it allows for small changes. It allows for a small sample. So that's a better thing. No doubt this value is slightly less than this one, slightly less, not much, slightly only. Now my sample size is only 90. If I had gone for say 400, 350, then you don't see much difference here. They will be almost equal. But anyhow, always go for the adjusted R-square. Adjusted. That's why it's called adjusted. It allows for all those errors and all that. So adjusted R-square is so much, 49. But this is a number 0.493. But when you interpret, we interpret as 49.3% of the variation in the pedagogy is contributed by personality. That's the wording. That's the interpretation I make out of this model. 49.3% of the variations in the pedagogy is because of personality. One. That's the understanding, that's the interpretation. So you can see that again in your R-squared change. See, R-squared change says the same thing. They say the same thing. But this one, they follow the first R-squared, whereas I'm following the 493. Okay? So look at this model summary, this first figure. Significant, then you start interpreting. If it's not significant, no point interpreting. Close shop. Okay? I hope you understand. When I say close shop means nothing more to talk lah. Finish already. Okay? So this is important. Then you go down here to the ANOVA. ANOVA, you may wonder, wait, what is ANOVA doing here? ANOVA is to find differences. Yeah, it is true. This ANOVA is to find difference. But difference is what? Difference in the hypothesis. There is a null hypothesis behind this ANOVA. The null is that there is a value for the slope of the straight line. Every straight line will have a slope. The m is the slope. Y equals to mx plus c. The m value is the slope. sometimes called gradient. So the null hypothesis here is M is 0. M is 0 means what? There is no line slanting. There's no slope. That's the understanding. So if this is 0, 0, that means you can reject the null. What does the null say? Null says there is no slope. So you reject it. So what is your answer? There is a slope. Okay, that's the meaning of this. It must be significant so that we can reject the null saying that no slope. But now we are rejecting it, so we know that the answer is there is a slope. Okay, we continue. We continue into the coefficient table. Coefficient table, you can see that Pearson has come in. And then here again, you have to see the significance. You know, how do we see? We have two sets. One is called unstandardized coefficient. We call it B value. Then over here, you have standardized coefficient beta value. They are different, but they almost say the same thing. Okay, they are different in the sense the calculation is different, the meaning is different, but they will somewhat tell you the amount of contribution from personality 1. So here I know that 70.6% of the variance in the pedagogy is contributed by personality. So you can see that 70.6, this one, always convert to percentage. It's in decimals, 0.706, but you have to times 100 to make it percentage. So 70.6% of the variance in the pedagogy, the DV, is attributed by the variance in personality. And is it significant? Yes, look at here, is significant. This is so important. If this can be any figure, and if this is not significant, forget about it. Don't talk about it. Okay? Forget about it. This too, I will explain when I'm using multiple regression. Now you don't see any value, you only see 1.1 like that. But when you are doing multiple, this values will change. Will be no more 1. It will change. Okay, that time I show you. I talk to you. Okay, then finally you see case-wise diagnostics and all that, and then residual, all this. These are not so important for you. What is more important, you see, in this table is this one, this table, model summary. Start with the significant and move over here to the talk about the percentage of variance attributed to the IV. Then come down here, check the ANOVA, whether the model is okay, can be used or not. Then come down to the coefficient, look at the significance, and talk about the contribution of personality. Any question, class? Any question? If not, I'm going to show one more from the same data. You see, I'm going back to the, you see, can you see this shortcut? The moment I've done a new one, the new one will come number 1. All that I did earlier in the morning, that analysis, all go down already. So this is the latest one. So you press, you get the table. As long as I don't disturb all this side, they remain, you know, you just see, all will remain. So you don't have to redo all that. So you try to play with this icon here. Okay. Then this time I still have pedagogy 1. I don't want personality. What I want is I want context knowledge. So I put context knowledge, put inside. Then say, okay. So you have got a new model, new model, new correlation. Again, you look at the correlation. Context and pedagogy is 0.836. Very high correlation, very high correlation. But this is okay because you are correlating with IV and DV. It's okay. That means it's a better model, better correlation. The high correlation should not be observed, should not be seen among the various IVs. One IV and another IV should not be this high. They should be less than 0.7. But IV and DV, it's okay. The stronger, the better. Okay, it cannot be weak, it should be stronger. So this one is okay, accepted. And then go down here like just now, look at the model summary, look at the F value, is significant. Yes, it is significant. Look over here, adjusted 69. So how do I interpret? 69.6% of the variance in the pedagogy is attributed or is because of context knowledge. That's my interpretation. Then you go down here, ANOVA. Again, you see this ANOVA is correct. That means the model that we are chasing after is correct. And then go down here, coefficient, significant, very significant. That means the contribution of context knowledge towards pedagogy is very good. And it's about, what is it? It's about 83.6%. Okay, 83.6. Over here also you can see, then the significance and all that, 83.6. The rest of the tables, leave them because we are not having any issue with that. Okay, so 2 examples for linear. I'm moving to multiple now because linear nothing much to learn, very simple. So I'm going to show you multiple. Sorry, I can go to the same icon here, make it very fast. So I'm not disturbing anything here. Here only I'm going to disturb. Just now context only. Now what I do, I'm going to put in more than one. What is the other one? I put personality. So now I see 1 DV, 2 IVs. This is called multiple, standard multiple regression. Okay, just now I only checked whether the IV predicts or not. Then I got some value. I told you 70.6% it predicts, 69 or whatever I'm saying. That is because 1 and 1. Now got 2. So the prediction power will be different. Context knowledge will predict differently. Personality will predict differently. Okay, so let's see how is the prediction. Let me run it. I've run it. So the regression, correlation, you look now. Okay, I told you the correlation between IV and DV must be good, more than 0.3. But the correlation between IV and another IV must be less than 0.7. We check it out. You see, our DV is pedagogy. So pedagogy, where is pedagogy? Here, this is the pedagogy column. Context knowledge with pedagogy, that means IV with DV, 8.3 is a good one. 722 also good. Okay. Between these two IV, that means context knowledge with personality. Look at it, 0.623, less than 0.7. Okay, good. It's not too strong. See, that's how you check. Okay, that's how you check. IV and DV, the correlation must be strong, but IV and another IV, the correlation must not be more than 0.7. So this is a very good example of the correlation satisfaction. And then we go down here again, you look at this significant 0, come over here, 76.6% R squared, or adjusted R squared is 76. What does this mean? When it was linear, it was easy for me to predict because 1 DV, 1 IV. So whatever number I saw, I give all the number to that IV. I said personality contributes 76 point something percent. Very easy to interpret. But now I have 2 IVs. And what you see is a combined number, combined effect. So what I'm seeing here is the combined number, combined effect of both personality and context knowledge. So together, context knowledge plus personality together as a set, they contribute 76%. That is the interpretation. Just now linear, 1 only contribute. Now got 2. So you are saying the set of variables, context and the personality, both combined, they produce 76% variance. Then model here again, significance. Okay, then come down to the coefficient. This time you will see 2 rows. See, you are seeing 2 rows. One is for the context knowledge, another is for the personality. Then look around here. Look here. This is the standard beta, standardized beta. 63.2%. Let me see. What do you see here? You see about 76%, isn't it? The total is 76%. Now here, 63.2% is from context knowledge. Another portion is from personality. When we have a multiple correlation, it is better to look at this portion here, the part. See, this is called part correlation, part and partial correlation. This is a better figure because just now you saw total 76.0. When they come together, when both personality and the pedagogy, personality and the contextuality together, they contribute or predict 76.9%. Here is the separation. The first one, context, contributes 49%. The second one contributes 25%. So when you add up, it will give you the 76. Okay, so this is a different thing. Multiple, you go to the part and partial figures, numbers. Okay, in our class, do you follow? Okay, linear, very easy. Multiple, you have a separate table and separate, because there are two IVs, not one. This table, this model table will give you together. Together, they contribute 76. But personality, how much? Context, how much? You don't know here. You can't find that figure here. So you have to come down to the coefficient, especially along these two rows, especially in this region, part, P-A-R-T. Okay, so the first one, which is the context, gives you 49.4%, and the second one gives 25.7. So when you add up the two, you may get about 75 plus or 76. Okay, now class. I'll show you one more. Don't worry, I will show you one more on multiple. But definitely, when you go back today after my class, wait, just see if it's being recorded. Yes, it's recording. So I will pass this to the BB. You can replay and check. Okay, how we did. Okay, so I'm going to show one more multiple. I'm going to show you one more multiple. Maybe this time 3. I put in 3, one shot. So don't disturb this. Add one more now. What is that I'm going to add? I'm going to put in student knowledge. See, I'm going to put student knowledge inside. Context finished. I'm going to bring in student knowledge inside. Okay. See, so many ways of bringing in. Either you hold and bring it, or you highlight and then use the arrow. Either way, you can bring it. But the important thing, it must come inside this small window. Your DV, now IVs, there are 3 IVs: context knowledge, personality, student knowledge. I'm going to run the regression. This is now called multiple regression because more than one IV, one DV. Okay, I've done the regression. Look again into the correlation just to satisfy yourself. Our DV is pedagogy. Our context knowledge with the pedagogy is quite strong. Personality with the pedagogy is also strong. The student knowledge with the pedagogy is strong. So it's beautiful because the IV must be correlated strongly with the DV. But among the IV, not strong, shouldn't be strong. So this time I'm going for one, just pick one of them, the context knowledge, and then check its relationship with the personality. 0.6, good. 0.8, not good. Okay. Student knowledge and context knowledge, you see, they are almost very high, 0.80. I cannot repair it. If it is like that, I can't repair much because I cannot go and change the data. See, it was the data given, but no, you know yourself that the IV and another IV, they seem to be very strong. Okay, but there is one more way to check whether they are collinear, whether they are strong enough to be considered like twins or not. If they become twins, then you have to remove one. So let's check another place. There is another place where you can check whether they are very close to each other or not. So where to check? I'll show you in a while. Before that, coming back to the model summary, once again, look at the significance here. It's 0, 0, and then look at the adjusted R squared, 79.2%. What does that mean? 79.2% of the variations in the DV, which is pedagogy for us, is attributed by the set of IVs, namely personality, context knowledge, and the student knowledge. That means 3 IVs combined together, they produce 79.2%. That is the interpretation. Look here, significant, then go here, take the value and try to interpret. This is now a set of 3 variables, not 1, not 2, more than 2, 3 variables, okay? And we know it is 79.2. Then come down here to the model, the ANOVA model, significant, very good. So we have a good model. And the coefficient now, look at the coefficient.
Wait.
Look at the coefficient, okay? So there are 3 here, 3 here. So let's see how they fall, okay? How they fall. Look at the significant, 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 significant. That means all the 3 are contributing significantly. But how is the contribution? This part and parts will tell you. First one, the context contributes the most, 25%, about 25%. The second one, the personality, is contributing 16.1. That means it's not number 2, you know. The student knowledge is contributing more, 18.2. So that is the contribution now, individually. Individually, they contribute like that. When you combine, then the effect will be 79.2. I need to remind you something. You don't see these variables as something like they are very remote. They are remote, like for example, a personality is there, and then context knowledge is there, student knowledge is here. Don't think they are existing just like that. They will interact. They will mix with each other. They will mix with each other. Interaction will occur. That's why you cannot see the percentage of contribution or percentage of variance to be increasing all the while. It's somewhere there only. The mix will take care of the contribution from each. Okay? That's reality. Reality, they can combine, they can interact, they can bring one down, another will be better. So all this will happen. We can't see, but it's happening there. So don't assume that, oh, this one is, just now it was 20. I put only 1, it was 20. Or for example, put 1 only is 80. But when I put 2, it's no more 80. By right, it should be more, isn't it? Because this time I'm pushing 2. No, that's not true. It may come down because now the interaction is happening. And maybe the interaction is bringing down the DV. Or maybe the interaction is bringing up the DV, possible. So we do not know. We let the statistics handle that part. Okay. So in the multiple, this is what we see. This is what we do. Okay. I've shown you 2 examples here, 2 examples there. Okay, non-class. Do you need some more examples?
Doctor,
Yes.
question. So in the previous example of the linear regression, there is 1 dV.
Yes.
And why the value of R square and the beta are different? Is both of them means the contribution percentage to the IV?
No, they work on different calculations. R square works differently from significance. Usually the first row, the first value will be same. The second row will be different.
So different standard.
Come again, different?
It means so there are different standard, different criteria.
Different criteria. Don't say standard, different criteria.
Okay.
Different way of calculating. Okay, R squared.
Okay.
Okay, and then, but roughly you can get the percentage. Supposing you are interested in finding out which is the best predictor, then there is an answer there. You'll know from the contribution, you know that it's the best predictor. But normally, if there is a question asking you which is the best predictor among this, we don't use multiple regression. We use stepwise regression. There's another technique that can tell you straight what is the best predictor. Instead of we doing everything and we ourselves finding out, it will find us the best predictor. I'm going to show you next. Okay. My question just now was, do you need some more examples on the multiple, or can I move to the stepwise?
It's okay.
It's okay. I can move to the stepwise. Huh? Okay. But I'm using the same data. I explained to you why I'm using the same data, because it's already now in your mind. The DV is pedagogy, the IVs are all this. So it's easier for me to work on that. That's why I'm using the same data. But I have a lot of data down there. If you need them for tutorial, I can just pass them to you. You can work and try. Okay, something like that. Okay, now, sorry. I'm going to show you stepwise regression. So I'm going to analyze first, back to regression. That is the one, regression. Okay. Then linear. Even though I'm going to use stepwise, even though I'm going to use multiple, the initial procedure is same. Analyze, regression, linear. That's the entry. That is the entry to the process. So you come through that path. Analyze, regression, linear. Then only it opens up the screen. This is where you change from multiple to stepwise, from stepwise to hierarchical, whatever. This is where the change happens. So once again, I'm going to keep this pedagogy here. I'm going to keep this 3. But my question now is, I've seen all 3 are contributing. All 3 are contributing. So now my question is that I want to find which is the best predictor. Best predictor. That means which one contributes more. That is called best predictor. Okay. If 2 means better predictor. If more than 2, we can use the word best. Okay. According to English lah. If only 2, you can't say best lah. You can say better. Which is better. But if you have more than 2 or 3, then it's proper to use best. Okay, I'm using now best, which is the best predictor among context, personality, student knowledge. So the statistics remain the same. Huh? All the statistics remain the same. The plots, I'm not using the plots. Safe also, I'm not using options, of course. Lah. I just ensure that this exclude is there. The rest all don't touch, don't have touch. Options finish already. Style no need. Bootstrap no need. Okay. Bootstrap is more for smart PLS. Okay, because they have a different way of using bootstrap. Okay, here, this is where we confirm what we want to do. All this while, the linear regression, the multiple regression, I did not do anything here because I left it as the enter. Actually, if you drop this menu, drop down, you see many methods here, a lot of methods. One of that is enter, another is stepwise, then remove, backward, forward. Okay, so I'm going to do stepwise now. So I press stepwise. So now my instruction is do a regression analysis, which is called stepwise. Why stepwise? Because it is going to enter the variable, especially IV, into the processing, into the analysis, one by one. Multiple regression will enter all together. If you give 10 also, all the 10 will go inside. If you give 2, all the 2 will go, all the 5 will go. It does not sort out. But stepwise is going to send 1 at a time. You can give 10, but it will send in first 1, then second 1, third 1. It may not send all the 10. Some may be stopped. Some may be removed. That's the whole idea of stepwise. So what is the criteria that it is stopping? It will stop when the contribution is very little. Because our question is we are looking for better indicator, better predictor. So it will only take in the highest contribution. High, take in, next high, take in, next high, take in. The moment the criteria says it's not high, then it won't process anymore. Stop. The process will stop. Okay, that's why it's called stepwise. Okay, I'm going to run it. Wow. Looks very similar. All regression will look similar. And again, you can see, because I didn't change, isn't it? I didn't change the variable. So nothing much to watch here. It's exactly the same. But always remember, you just do a check. Just do a check. IV and DV can be highly correlated, but IV and IB cannot. Okay. Okay, now this is interesting now. You see?
Mm.
This fella, this one.
Three models.
Let me go to, this is a multiple regression, you know, this is a multiple regression. And under this heading, variables entered, removed, you saw everything inside, one shot. There's only one model, one model only, and all the three are inside. But now this time, you see, this time, it's stepwise. You have three models. You have three variables. They have been entered one by one. Okay, so first, context knowledge went. Why context knowledge went first? Because context knowledge predicts a big portion of the prediction power for context is higher compared to student knowledge and personality. After context knowledge has been granted permission to enter the process, left with two more, student knowledge and personality. Next, highest, which is the highest among the two. Student knowledge is higher than personality. Then student knowledge will go into the model. After that, the remaining one is personality. Does personality still can offer a good percentage? If it can, it will go in. Otherwise, it will be removed and the process will stop. So now here I can see that all three have predictive powers. All three can predict. But the best predictor is context, followed by student, followed by personality. Okay, so now three models. All three models, you check the significance. And again, I'm telling you, you must check the significance. Then only you start talking. If suddenly you talk so much, and then you see here it's not significant, meaningless. Okay, so always come here, check this first. Okay, significant, less than 0.05, 0.05, 0.05. Okay, now we come over here, adjusted R square, adjusted R square. Okay, but if you want part, the R square change, this is the part, huh? You see, this one, adjusted R square and the R square change, they are very similar. Only thing, this one is total, this is the actual portion. Okay, you see here 69.6% given by the first model. First model is what? Context knowledge. The second model adds a bit only, a bit. From 69 it adds a bit to 76, make it 76. So in terms of the actual percentage extra that is provided by this is only 7.3%. Then the next one, the personality comes in, it adds from 76 to 79. That means the actual change. That's why it's called R squared change. This is R squared, this is R squared change. That means how much it changes from one model to another. So the first model gives you 70%, second model gives you 76, meaning that the second entry, the personality, I think personality, no, student knowledge comes in, it adds only 7%. Then the final personality comes in to enter, it only provides 2.6%. So from there, you know that the best predictor is context knowledge. First one. Next predictor, next batch, and then 3. Okay, now what I'm going to do, any question before I continue with the next one? Once again, you have to check the significance values here. All must be significant, then only whatever we say is meaningful. Otherwise, it becomes meaningless. Okay, if no question, what I'm going to do the stepwise again for you, but I'm going to put all my variables. Just now only 3, isn't it? All 3 also went into the SPSS. I want to put in all now. Linear regression, I already have 2. I still have 2 more here waiting. So subject knowledge is going in now. What is it? Knowledge of self is going in now. So all in how many now? Now I have 1, 2, 3, 4, 5. Okay now. So I'm putting in 5 IVs. I want to check which is the best. Just now I put in 3. I know what is the best. But all 3 also managed to come into my model. 1, 2, 3. Now I'm putting in 5, see whether how many can come in. I want to see how many can come in. Eh? So same buttons, nothing. I don't disturb this fella. So I go here, I just run it. Stepwise, keep it stepwise, run it. Nothing to check. Now you see how many models are there. I put in 5. Remember, I put in 5 variables, but I only see 4 models. What does that mean? Model 1, model 2, model 3, model 4. I'm supposed to have 5 models, isn't it? No.
Yes.
In stepwise, don't count that way. Don't you fix the number of models, because SPSS is doing it for you. It's not you are in direct, you only directed SPSS to do a stepwise. So SPSS will select the best contributor. So the first contributor, the best one, is context knowledge. It has taken into a model. Then the second best is knowledge of self. You know, knowledge of self. Just now we didn't put knowledge of self. But now when we put, you see, it has beaten the student knowledge, it has beaten the personality in terms of its contribution. So it comes in next. Then the third one is student knowledge comes in. Then the fourth one, personality. Subject knowledge doesn't contribute much. So it doesn't come in. Okay. So you see, I started with a model saying pedagogy depends on personality, depends on subject knowledge, student knowledge. That is from my literature review. But when it comes to the data collection, my sample, who are the China students, the Malaysian students, they gave me the data, which is telling me that subject knowledge has got no importance. So you see, theory is telling me subject is important, but the data I collected. Someone is talking.
复兴
Okay, can I talk now? Okay, I'll just continue.
Okay.
Somebody, they don't realize that the mic is on. You know, I switch off all the mics. Actually, over my place, I can mute all. But when you are speaking, you will switch on. After that, it's not under my control. It's your control now. You have taken the control. So I can mute all again, but I must go to the main one, and I can't be doing that all. Okay, so I sent in 5 because my literature review, literature reading and all that told me that I have about 5 variables. Subject knowledge is important, student knowledge is important, context knowledge important, personality of the teacher important. All these are important. So I put in all. But when I send this questionnaire to I even checked my questionnaire, and all validity, all basically same. So when I send it for the data collection, my sample answered me in such a manner that they say, or indirectly they are saying, subject knowledge is not important. See, they only claim context knowledge. Context, it's not content knowledge, you know. Content means subject knowledge, context knowledge. That means environment, the classroom and all that. And then self-knowledge, self of the teacher, beliefs, attitudes of the teacher. And then the student knowledge, okay, how much the teacher knows about the student. And finally, the personality of the teacher. They say these are the important things. So it can happen. If I take this questionnaire to another part of the world, maybe to India, maybe to some other place, New Zealand, Australia, or China. See, my students, sample, partially China students, PhD students, partially the Malaysian students, the BED students. So you see, different people perceive things differently, thereby they give response differently. That's why we say that when you change your setting, when you change your sample, when you're going to different parts of it, you need to do a lot of things, basic things. Okay, you can't assume that what is right in this province is also right in another province. May not be. Okay, coming back to this one. See, out of the 5 that I sent in, looks like 4 only contributing, 1 not contributing. We'll check it out in the model summary. You see model summary. significant, significant, significant. All the 4 models are significant. Come down a bit, look at the ANOVA. Model 1, significant, 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 beautiful. Come back here, look at the R-square adjustment. Look at the R-square and R-square change. Okay, look at the R-square change, yeah? First model, which only has context knowledge, 70% contribution. Second one, the knowledge of self, 8.1%. 8.1%. Then next one, student knowledge, I think, student knowledge, 3.3. Personality, 1.6. This is already very small, 1.6. I believe the subject knowledge may be even smaller than that. That's why SPSS stop processing the last part, because it's very small, very tiny. The contribution is so small that it doesn't want that. Okay, so this is how an SPSS, especially the stepwise, will run. Okay, this coefficient is also worth seeing. You look at the coefficient here. First, look at the significance. Significant, all significant. This is not significant. Okay, constant, no need lah. Constant, normally not significant. Look at the other values. All are significant or not? Yes, all of them all are less than 0.05. Okay, but the contribution. Look at the part. Okay, when the first fella context went in, it was like that, so high. But when the second one came in, they shared. One was 41.6, the other one was 28.4%. But the third one came in, the first one came down a bit, 21.2, second one was 20, third one was 18. Then the fourth one came in into the model. We had 19.8, 17.4, 12.8, 12.6. So from here, you know the best indicator is the top one, context knowledge. Okay, so for this sample, for this research, context knowledge is the best predictor for pedagogy. Maybe literature doesn't support, I don't know. I have to go back and check my literature, whether context knowledge is a better thing or not. But however, I will agree, let it be anything from the data, because data is from the sample. If the sample, the people, subject who participated in my study, they believe this way, then that is the result. If I go to some other place, my results may be different. So I do not say, that's why you see that when you are doing a literature review, literature survey, literature review, you will see that some findings are mixed. Some people say boys are better than girls. Another study may say girls are better. Some say they have almost same. See, how do you get that? Because they are coming from different samples, different cultures. That's why they keep on giving you different ideas, different perceptions. So when you bring it, the same idea, and you do a study in your place, that study may go either way. It may show boys are better, or it may show boys are not good, or boys and girls no different. It can say anything, because it can go into any idea, anywhere, depending on your setting, your culture, and your people. So do not be scared if your results in the research becomes non-significant. Don't worry, that is because your data. It's not that you are wrong. Okay, you assume a relationship significant because literature was telling you, but the literature also told you earlier there's a mixed findings. Some say yes, some say no. So when you come out, you say, oh, no relationship, so you belong to that group. That's all. You have not failed. You are successful, but you are successful in telling that your results suit the other group. Okay, something like that. That's how we interpret. Never say, oh, my results is wrong because I predicted a positive relationship, but it turned out to be negative. Because it's not you who can predict. It is the data. It is the response of the people you are studying. They predicted. They are telling you, this is our prediction. Okay, so this is what we see. Okay, this is what we see. Look at the significance and look at the part and parcel area. See, this is one, and you can get your prediction very well clearly from here. 19.8%. Okay, you may ask, how come when context was alone, 83.6, when I bring in the knowledge of self, it reduced. I told you just now, the variables are interactive. They interact among each other. You saw, isn't it? They are correlated. They are correlated. They are not uncorrelated. They have a correlation. Some are 0.8, some are 0.6. That means they correlate. They interact with each other. So they share the contribution. They divide the contribution. They share the contribution. Okay? So that's why you don't see the consistent number. You don't see 83, 83, 83 all for the same. No, it doesn't happen. It does not happen that way. Okay. So much so for stepwise. I'm going into the last one, which is called hierarchical. Okay, let me ask you one question before I go to the hierarchical. I'll show you this one, this piece. Can you see this window? I'm shaking it. Huh? I'm moving it. Can you see?
Yeah.
Yes.
Oh, okay, good, very good. So my question now is, the DV is still the same, pedagogy. And the IVs, there are 5 here. Okay, 5. And I told you that all the IVs, they don't remain cool and quiet. They always interact with each other. Okay. You may wonder, you may think, what if I control these IVs and I want to see the action or the contribution of just one of the variables? I control this. I want to see the changes here. I control this. Let's say you have an idea of controlling any of the factors, any of the variables, and then see what happens to the other IV, how much it contributes. So this kind of questions where control is coming, you control one, you let the other move. You control two, you let other move. This kind of control effect you are bringing inside, then you have a method called hierarchical. Hierarchical means in layers, in blocks. So the SPSS allows you to do hierarchical by what I'm going to show you. Just watch out. I'm going to show you how to do an hierarchical and how to express them. Okay. I told you these variables are all interactive because they are correlated. They will always interact. That's why you cannot say, oh, context knowledge provides 80%. Yeah, 80% when it is alone. When it mixed with another one, it's no more 80%. It may come down to 60% because there is an interaction. But let's say that you want to find out, hey, what if I block, if I control one of the variables? I want to see how much it moves. Then this is the method, hierarchical method. Okay, so here, how do we put in? We put in one after another, but in different layers, blocks. So let's see, I want to put context knowledge. Yeah? I take context knowledge, I put it inside, and I call this one layer, layer 1. So I'll keep it as layer 1, and then I create layer 2. So the variable that I put is no more here. Now we are into the layer 2. Okay, into the layer 2. So what I do, I go and pick another one. Just now, what was the second one? Context, then no self. Okay, I put no self, I put in here. Then I say next. That one also goes to another layer. Okay, so we are now into third layer. First layer we had context. Second layer we had self knowledge. Third layer I'm going to put student knowledge. Okay, next, fourth layer. You see, we can go layers by layers. I have 5 what you call 5 IVs, so I can go for at least 5 layers. So next one is, I see subject knowledge. Okay, subject knowledge, one more layer. Next, the last layer, 5th layer. Okay, 5th layer is what is it? Subject, student, context. What? Personality. Haven't done yet. Okay, I'm going to put personality here. Okay, okay. Let me check. Let me just check. What was the previous? Previous was subject. Previous was student. Previous was no self. Context. Okay, 1, 2, 3, 4, 5. All there are 5 layers. That means you see, I didn't put all together. I'm putting in layers. A first layer. They don't mix. That means they don't mix. We are blocking one, seeing another. Blocking one, seeing another. That's kind of system. This remains as enter. but I have already decided on the layers here. So I'm going to run it now. I'm going to run. See, very similar. The results will appear very similar, but look at the variables entered. The first block. First block. Then you have no self, second layer, third layer, fourth layer, fifth layer. Okay, now look at here. Look at over here. Are they significant? This is significant, 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 not significant, significant. That means the fourth model, what is the fourth model? Subject knowledge. Just now also we saw subject knowledge doesn't give anything. No, does not produce any contribution. So again, you find that it has been decided, it has been told here that that model is useless. So model 4 is useless, though we don't talk about it. In other words, it's like you take off subject. So you only have 4. So why not I redo this with only 4 models or 4 layers. So let me go back. I don't want, okay, I don't want this. I redo. Subject knowledge, I don't want, I push it out. Later also I don't want. Okay, the rest, never mind, let's keep it. So instead of subject, I think I put personality there. So how many layers are there? Personality, student knowledge, no self, context. So 4 are there inside. 4 are there. Okay. Enter, still enter. It's not stepwise. And don't change this. Only stepwise will require stepwise. Otherwise, all enter. And then we press. Of course, I will have only 4 models here. 1, 2, 3, 4. So the first model is context. Just now, why did I push off subject? Because very clearly it shows that subject doesn't contribute. So it's not used, not worth putting it anymore. Just remove it. So we just go into the 4th model, 4 model. All the 4 are significant. Even though the last one is a bit, it's still significant at 0.05, but compared to the others, it's a bit less, but it's still significant. And then look at here, all the 4 are significant. Okay, with this, we go and talk about 69.6, over here, 70. And then this one is what? 8% extra, 3.3 extra, 1 point extra. As the model, as you block the rest and check, this is the answer. Well, what does it mean is that the first model, there are no disturbances. We are only watching the context knowledge contribution. So that's why it's 70.0. But the second time you are looking, you are controlling the context knowledge, and you're observing only the contribution of the second fellow, I think it is self-knowledge. This is self-knowledge. So I noticed that self-knowledge alone, without the interaction with the others, the contribution is 8.1. Okay, next one. Here, down here, the third one. Third one is 3.3, meaning that I'm controlling context, I'm controlling the knowledge of self, I'm observing the student knowledge now. So only student knowledge is allowed to play. The rest the other two are blocked. Okay, so it provides about 3.3%. Then I go to the last one. The 3 of these are completely blocked. So I'm only allowing this last fella, which is the personality, to contribute. And I'm observing how much is the contribution. The contribution is only 1.6. So you see, this is one additional regression family method which allows you to control something and then look at the other variable. If you don't control, all will be acting simultaneously, all will be functioning simultaneously, all will be interacting at the same time. So your contributions, you cannot identify individually. It's a bit difficult, okay? It's a bit difficult. Okay, look at the part, see part. Okay, in the part also you can see very closely. They are like 19, 17, 12, and 12. You see, 12 and 12 are very close. And the last 2 are very close. Okay, that is hierarchical. No more regression. No? These are the 4 types of regression. All this collinearity. I forgot to show you something on this one. Okay, this coefficient. The last two rows, they talk about collinearity. I've been telling you what is collinearity. Yeah? Collinearity means they are almost same. If I have one variable and the collinearity of this variable, call it A, call it A. Variable A, if it is collinear with variable B, collinear means that both are measuring the same thing, almost the same way. So same contribution, same effect, same influence. So what we do, we normally don't keep them in the measurement. We will take one now. You can choose to take one of that. One of the two only remains, the other goes off. So that is our principle. So how do we check? We check here. There are two units for you to check. One is called tolerance. You see, both are collinearity statistics. One is called tolerance. Another is called VIF. VIF stands for variance inflation factor. VIF. So what is the criteria? The tolerance must be more than 0.1. Okay, the value must be more than 0.1. Don't look at this and say, hey, this is one. No, this is only one factor going in. Okay? Only when you have more than one IV, you can compare, isn't it? Whether they are linear, collinear or not. When you have only one, the collinearity, there's no meaning for it. So when you bring in another variable, then you can observe the collinearity. That's why this is still 1. But here you see, when I bring in one more, it's 0.5. So as long as these numbers, all the numbers are greater, more than 0.1, then they are not collinear. They are not collinear. Similarly, you can use on the other side here, this side, also for the same reasons, collinearity statistics. Here the criterion is the numbers must not be more than 10. 1 point, 2 point, 3 point, 4 point, all that are allowed. See, got 2 point, 3 point, 4 point, 6 point, 7 point, 8 point, 9 point allowed. 10 above not allowed. Once you see a 10 here, that means that variable is collinear with another variable. So you must find out which is the variable and you have to take that, one of them. Okay, so this is another way of checking collinearity. So that's why this comes in here. So it's very, very easy. Just look whether it's more than 0.1 and this side less than 10. 10, this is 0.1, 0.1, this is more than 10. This is more than 0.1. So these are the statistics for you to look for when you do a stepwise multiple or hierarchical. The name is hierarchical, not hierarchical. No, don't say chical. It's key. Hierarchical. Okay, any question? I'm almost finished. I'm done. Wait, sorry.
difficult.
He didn't give you the examples. Wait. Any question? I need to show you some examples. Okay. Any question, class? This is being taped. This is being recorded, so you can have a second time listening to that, and you can, if you're not sure, you can see that because it's a video recording, isn't it? So it will be recorded. Of course, you can't see me because I'm not showing my face, but you can see all the things that we are showing here on the screen. Whatever you see on the screen are there on the record. So if you don't have a question, I'm going to show you an example. Okay, an example. I'll just run through this one. Just run through because I finished already my what do you call my multiple regression, and you see 2 or more. And then all these are notes only for you. See, multiple means more than 2. Okay, more than 1. Then what sort of question it will answer? It will answer when you bring in more than 2 IVs and 1 DV. Okay, how well? Standard multiple. And what about this one? You see, 3 variables still can use multiple. The question, type of question would be how well gender, happiness, and validity. You just continue first variable, second variable, third variable, how they affect the DV, reaction time. It's called standard multiple. Okay, all these are come under standard multiple. Mental health being influenced by depression score, anxiety score, family support score. Okay, so 3 variables are affecting. So the mental health will be DV, the other three are IVs. Okay. The question can be like this: how well depression score, anxiety score, family support are able to predict? It's all prediction. Huh? 1, 2, 3. And then the DV is there. Standard multiple. Okay. The stepwise is like this. Researcher provides a list of independent variables, like what I did. I sent in 5, then allow the program SPSS to select which variable it will enter. So the selection is done by SPSS based on the criteria of which one has more predictive power. So based on that, it will bring in the first IV into the model. Call it model 1. Then it will bring the second prominent one into the model, call it model 2, and so on, until it decides not to bring in anymore, because it will know that the contribution is very little, so it will stop. Okay, this is the analysis to test which of the variable is a better predictor. Okay, so the moment the question asks predictor, better predictor, remember the method is stepwise regression. Okay, which of the variables among depression, anxiety, family is a better or are better? Why am I using is or are? Sometimes you have more than one predictors. You may have the best predictor followed by the next one. So depending on the question, if the question say best, you pick the first fella. If the question say which are the predictors, if you just say which are the predictors, then you have to give all the predictors, all one by one, 1, 2, 3, all. Okay, depends on the question. Predictors, stepwise multiple. Okay, I've done it. Then finally, it's a hierarchical multiple regression. This one is when the variables or sets of variables are entered in steps, with each independent being assessed in terms of what it adds to the prediction of the dependent after the previous have been controlled for. So when you impose some control, you don't let him move. You hold the variable and just let the new variable to move, meaning to change. Then that is called hierarchical regression, multiple regression. Okay, something like that. Let's say I want to see what is the depression score. So I hold the anxiety and family. Hold means not to say keep it outside. Keep it inside the model, but hold it by putting it in different layers. Okay. Don't try to think out, oh, since I want to see depression, I don't enter anxiety and family lah. So I just put depression lah. Yeah, but that is linear regression. It's not a multiple regression because you're only putting one variable inside. So it is considered linear. You don't see what you want. What you want is, I want everything to be there, but then I control these two. That is hierarchy. So put in all three, but when you put them in layers. First put depression, then put anxiety, then put in different layers. Because the SPSS will provide you layers. First time you put, next only it provides you second layer, then second layer, third layer, fourth layer, fifth, it goes on. Okay? So you can put that and then you can see in reality. What I'm saying is reality. Huh? In reality, all the variables IVs, they will interact with each other because they are correlated. They will interact and change your contribution. You cannot say, oh, this one just now gave me 20, so this time also will give 20. No, this time when you add more variables, it will come down. Okay, it will come down to maybe 18 or 19. Then the other one will take some share. Okay, and the kind of question for the hierarchical. Whether family support is still able, I see the question itself is different. Whether family support is still able to predict mental health when the effects of anxiety, depression are controlled for. This is a different type of question. You go back and read this a few times until you are clear. Okay, until you are clear. Hierarchical multiple correlation. Okay, same thing. Let's say I want to check what is the effect of mastery of internal modes when the other three are controlled. So you put them in the layer. Age one layer, mastery of external one layer, mastery of internal one layer, social another layer. Then you control the others, check mastery. Okay. So it's as a, what do you call, as a conclusion for what I've been doing today. This is one side, one slide that can help you to remember things. So when you are having a question like this, how well a variable, one variable, is able to predict another variable called DV, then the technique will be what? What is the technique for the first one? There are 4 questions here. Tell me.
Linear regression.
Yes, the first one is linear, sorry. First one is linear regression because one variable against one DV. So it's normally, look at the second question. How well a set of variables, that means many variables combined, what is the effect? So it's a multiple correlation, standard multiple correlation, okay? Which variable in the set is the best predictor? So you're looking after or for best predictor. So your method is stepwise multiple regression. Or if you think that, okay, I have so many variables, but I want to know them, what is the prediction in reality? When I let all of them loose, they're all interacting, but then I control 1 or 2. Then it is hierarchical. Okay, when the effects of other variables are controlled for. Okay, so these are the way we answer the question. I'm going to show you some examples. This one is the same thing. Okay, let's say this is your DV, IV. You want to control, you want to do anything also you can do. Okay, actually this is all results of the EFA. EFA was giving me all this result. How to reduce the pedagogy into 2 groups and only take pedagogy 1, because I did some research on this and I noticed that pedagogy 2 does not measure all the things, and similarly personality 2 also doesn't contribute. So that's why I dropped the personality 2, I dropped the pedagogy 2, I just only used the others. Okay, so this is my model. If you ask me what is the model for your study, this has become my model now. Okay, now I'm going to show you one more slide on what shall I say, on examples. Let me show you. Okay, this is it. Final one. I'm going to show you a final one before we say bye bye. Okay, where is it? Okay, example 1. This is actually a study, a present study by one of my students. She is doing a fully quantitative study, and her title, her questions, all are here for you. Okay, let's look. This is her model. Mobile technology and collaborative learning in engineering education. So her DV is collaborative learning, but inside the DV got so many dimensions. Okay, and then her IV is mobile technology. Inside the mobile technology, she has a few dimensions: mobility, accessibility, medias. And this side on the DV, she has a lot. But basically, the big variable is collaborative learning on the right, mobile technology on the left. Research questions. Her research question. There are 4 research questions she has put on, and this is the research question. What are the levels of collaborative learning in terms of each of them? What statistics or what analysis we should be doing? Tell me. Can you tell me what analysis we should be doing to find the levels of collaborative learning? Descriptive. And particularly what? Means. The mean value. And then you check. Of course, after getting the mean, you have to create the level, which mean what value of the mean will qualify for the high level, what value of the mean qualify the moderate level, what value of the mean will qualify for the low level. That one you have to create. You have to come up with the levels. And after that, you get the mean value, you compare with your level, and then you speak. You say, oh, this level, the level of interdependence is high, level of interaction is moderate, level of accountability is low, things like that. So it's a descriptive analysis. What about number 2? What are the levels of mobile technology in each of the 3 dimensions? Mobility, accessibility, and immediacy. Same thing.
Yeah.
Level. Again, it's descriptive. Descriptive using means, same thing. Identify the levels, either high, moderate, or low. So these two questions, very easy, it's descriptive. Let's look at the third question. Is there a significant relationship between mobile technology and collaborative? So my IV here is collaborative learning. Sorry, DV is collaborative learning. My IV is mobile technology. So I have a score for my mobile, one score. I have a score for collaborative. So is there a significant means? What statistics is that? It can be a linear regression, or you can even use a correlation matrix, Pearson moment correlation. You see, you have a correlation technique, or you can use a linear relationship because it's one-to-one. Okay, one-to-one. Look at number 4. Which of the dimensions, 3 dimensions, which of the 3 dimensions is a better predictor or predicts? So you have 3 variables here: mobility, accessibility, immediacy. So the question is, which one of them is a better predictor? So this is literally stepwise multiple regression. So look at the data analysis that she provides in her write-up. You see how she writes? She writes the question, she writes the analysis. She writes the question, she writes the analysis. Question, analysis, question, analysis. Look at it, look at it. I'm sure by now you should know what method to use, and you know how to use. We have done all this, we have done all this. Finding the means, you know, finding the standard, you know, finding the Pearson correlation, you know, finding these stepwise or doing the stepwise, you know them. So it's not an issue. And this is what I've been telling you. By the end of today, you will know how to analyze your questions, what analysis to use, because not many analysis here, either t-test, ANOVA, regression, linear, multiple, stepwise. Very seldom we do hierarchical, because some people don't even know what is hierarchical, so they don't know how to set the question, so they never go into that area. They only do up to stepwise. Okay? Is that okay now? I'm going to show you one more example, second example. This is first example. I'll show you one more example. Example 2. Why? Something very familiar with you. I am giving you the model. I am giving you the research question. Now you tell me the answers. You tell me.
The first one.
Number 1, what is the method?
The mean and the
Standard deviation.
Yes.
Correct. Okay, correct. Descriptive. That is descriptive. That means you need to find the mean and the standard deviation. Use the mean and then go to check with the levels. You see, the mean you can get from your data, but the levels you must create. You must create, because let's say I give a scale 1 to 7. So all my values will be within 1 to 7. So when I work out my mean, I may get a value between 1 and 7. Maybe my mean may be 5 point something. And then 5 point something is what? Is it moderate? Is it high? It is low? So you have to come up with another table. What do you mean by low? What do you mean by moderate? What do you mean by high? How do you do that? Very easy. Since you have a scale 1 to 7, you divide that into 3 parts. 1, 2, 3, 4. Divide into 2 parts. The lower part, the 3 parts, and divide into 3 parts. The lower part is the low level. The middle part is the moderate level. The top part will be high level. So once you get the mean, you bring the mean over to this table and check where it is. If it goes to the lower part, then your level is low. If it goes to the middle part, then your level is moderate. If it goes to the high part, then it is high. That's easy, very easy. It's descriptive. Same thing for number 2. What are the levels? Same thing. Look for the personality score, look for the subject knowledge score, and then check with the table, and then you answer. So 1 and 2, descriptive. Look at number 3. Is there a significant relationship between the IVs and the pedagogy? I got 4 IVs. 4 or 5 IVs. 5. So I work on that. I will work on that. I will just find correlation matrix, and then you check the relationship between the two, see whether it's relevant, significant. If it is significant, then you will see the star, asterisk mark on top. If you don't see, they are not significant. That's the answer. IV1, which is personality and context, knowledge, maybe we just take these 2. If you see the correlation, if it doesn't show you an asterisk or a star on top of the number, then it is not significant. Next one, go to the next pair. Check whether got star or not. If not, not significant. I keep on doing that. If there is a star, then 1 star means significant at p equals to 0.05. Double star means significant at p equals to 0.01. 3 star means significant at p equals to 0.001. 2 zeros, huh? That's the highest level. That means 99.9%. You are right. Okay, I think I've done. The last part is which of the thing is a stepwise. There you are. The answers are here. Okay, so this is how we produce our proposal defense. This is how we find the analysis session and all that. So all that comes here. All that comes. So now you know already how to do. So you yourself can determine, can decide on the method for analysis. Okay, only 2 methods: descriptive. The other part is called inferential. When you're doing a test, you call it inferential test. When you're just looking at the mean and getting the value straight from the table, it is descriptive. T-test is a test, so it's inferential. ANOVA is a test, inferential. Linear regression is a inferential, because you're looking for significant relationship. Stepwise, significant relationship. Predictor is inferential. Multiple, inferential. Hierarchical, also inferential. All these are inferential. Okay, so you have to know the difference between the 2. Okay, class, I think I've done. I will give you or pass the assignment 2 by tomorrow. Look for the BB. I will, the moment I upload, I will inform Juliet, and then she will communicate with you. Then you go and have a look at the assignment and do it. And the due date is next Friday. For the assignment 2 is next Friday, next week Friday. But assignment 1 this week Friday. Don't send together both. I mean, no need to send together. You can send the first one this week. You can send the second one next week. Take your time. Take your time. Take your time. Maybe a few days, 3 days, 4 days, 5 days. Just think carefully. Write it out, because you need to write something. You need to do some interpretation and all that. So you do it carefully, because I'm going to give marks for that, and that marks will come back to you as your results. Okay. So later, when you look at your results for AQRM, quantitative, that's your marks. Where did you get the marks? The combination of assignment 1 and 2. Okay, it's a mean score between assignment 1 and assignment 2. Okay, or maybe the total score, assignment 1 and it could be either way. I may decide to give 100, 100 and then take the mean, or I may give you 50, 50 and take the total. It's up to me now. Okay. Any question, class? I have finished my lessons for the day and also for the semester. Yes.
Doctor?
Yeah.
There have many questions. Okay. So for these 2 research questions, we know how to do.
Yes.
The first one by means and the standard deviations, but I don't know how to answer. See, if I know the means is 5, and how I should answer, explain, interpret this in the question.
Okay. Because the question, if you look at the question, it's asking for the level. It's not asking you for the mean, you know. It is not telling you what is the mean. It says what is the level. So there is there's a connection between mean and level. Mean is what you get from the statistics. Once you got your mean value, for example, like what you see, 5.3. Next, you go and check. You remember that we provided a scale for our subjects to respond. We gave them a scale 1 to 7. So they gave some responses 4, 5, 6, 7 or whatever. Then the mean value is now 5 point something. So you have to take this mean 5.1, go back to the scale 1 to 7 and check where it is sitting. If you bring the number 5 inside the scale, where does it sit? Is it sitting in the middle? Is it sitting on top? Is it, higher part, or is it sitting in the lower part? If it sits in the lower part, for example, if the mean is 2 or 3, then it is low on a scale of 1 to 7. On a scale of 1 to 7, a value of 1, 2, 3 is low. A value of 3.5 to 4, 4.5, maybe until 5, 5. Is moderate. A value more than 5.5, 6, 6.57 is high. That's how we conclude, we give the answer. You will get the mean, but from the mean, you determine your level. That's how you answer the question. What is the level? They are not asking you what is the mean. They are asking you what is the level of the score. The score will give you mean. Take the mean, put it on the scale 1 to 7, and see where it is sitting. Is it sitting closer to 1 or is it sitting closer to 7? If it is closer to 1, then the level is low. If it is sitting closer to number 7, then it is high. If it's sitting in the middle, then it is moderate. Okay, that's my answer for you.
So, the scale is divided by myself?
Yes, everybody also will have the same level. Don't worry. If you decide, and then for one candidate, all the candidates also will be same. You have to divide the scale 1 to 7 to 3, and then get the accurate value. Then using that, you divide your 1 to 7 scale into 3 parts: lower part, middle part, higher part. The lower part is what you call low level. The middle one you say moderate level. The upper one you say high level. Okay.
Okay, so I just to say the mean is how much, and it stands for the high level or moderate level or low level. It's good answer.
Very beautiful. That's it. You're right.
Okay.
Mention the mean and then you say the level.
Okay.
Any more question, class? I'm sure you have a lot of questions, but you can't just keep asking because you don't have any data. You ask me on the theoretical side, something like that maybe. But if you ask me too specific on the calculation or on the procedure, may not be very helpful to you because you are not doing any analysis now. You are not doing. Perhaps my assignment will make you do lah, because assignment I'm going to ask you to do and then answer. So you may use it there. But other than that, you don't have your own data. You're not holding any data. You're not looking for any analysis answers and all that. So still your interest may not be very high. That's what I have learned. I think that's what I am observing. When you need, then is the time you will look for the method. You will look for the analysis technique. Now you don't need, because you don't have a data. You're not much worried about the data and all that. But later, when you finish your proposal defense, when you've collected the pilot test, you need the analysis. Later, when you go into the real study, you collect the data, you need the analysis. Okay? So these are the moments where you will really hunt for people who will teach you how to do. No need to teach you. You yourself can learn. See? You go through my notes, you go through the recording I've done today. Okay? It should help you. Any more questions?
May I ask the second one?
What is second one?
For yes, like for the significant, like significant p
Significant. Okay.
equals
Okay.
significant.
No, this significant
Okay.
is there significant. What you do, you take these two variables, go to. I show you some.
Yeah, I mean, they're always
Okay. Like this.
use the 0.
Wait. I'm going to show you one example. Okay, are you seeing the table now? Are you seeing? Can you
Yes, I
see
can
the
see.
screen, the table? This is the data, I know. This is the data. Okay.
Yes.
Okay. Let's say I have the question: is there a significant relationship between vitality and reaction time? Okay, a similar question. Is there a significant relationship between vitality and action time? What I do, I go to analyze, correlate, bivariate. Because bi means two. You are comparing two variables. So bivariate, click. You get a window like that. You just send these two fellas, vitality inside, reaction time inside, and over here in the options, nothing, just exclude only, nothing much. See? You don't need the means and all that. You don't need all that. Then style also you don't need. For me, nothing. Style, bootstrap, nothing. Just here you need. You see, if the data, the vitality, the reaction time, and the happiness, they are measured on an interval scale, then you use Pearson. You tick the Pearson. If they are not interval, they are just ordinal only or nominal, then you use this last one, Spearman. You can see, I can check both for you. Both will come out. You check the values. They are a bit different. But according to the statisticians, if they are interval, you can use this. If they are not interval, you must use this. And they are not interval, you use this, they will scold you. Okay? They will scold you. They don't like you to use wrong methods. Okay. Flag means when it is significant, there will be an indication, maybe an asterisk mark. That's what we mean by flag significant. So I'm going to show you now. Not here. We have to go to the output. Don't assume the output will come here. This is the data view. So go to the output. Yeah, this is out. Okay. Okay. Correlation between vitality and this. So this is the relationship. The relationship between Pearson and vitality and correlation. Yeah, this is the value. Negative 0.052. So small. Negative and yet very weak. See? So it's significant, definitely not significant. Okay. This is Pearson correlation matrix. The bottom is Spearman. This is Spearman's row model. You see, the values may be different, but still must be non-significant. You cannot get significance on top and no significance down, or vice versa, because they are different techniques. But they always use similar technique. This one, when you have ordinal or nominal data. This one when you have interval or ratio data. So that's why one is Pearson correlation for interval and above. This is for nominal and okay. Let's try one more. Show you one more. Okay, one more bivariate. Let's say I push the vitality. I put the happiness inside. Let's see whether it is good or not. Look at this. Look at this. What can you say about this?
It's 0.466.
Okay, just the number alone. Just the number alone, 466 is moderate. It's not high, it's not low. It's moderate, between 0.3 and 0.7, you know. So it's a moderate.
0.3 and 0.7.
Yes, between 0.3 and 0.7 is moderate. Less than 0.3 is weak. More than 0.7 is good and strong. So now I can see that between 0.466 is somewhere in the middle. So it's moderate. But then you see the asterisk on top. Asterisk, one asterisk means significant at 0.05. Two asterisk means significant at 0.01. So this is significant shift. So the question says, is there a significant relationship between reaction time and happiness? Yes, the answer is yes. The significance is at p equals to 0.05 and the correlation is 0.46. That's the answer. So that's what we mean by significant relationship. So see whether you can get an asterisk or not. Okay. But of course, the second one, the last question is not from Pearson. The last question you saw just now. What was the last question? Okay, sorry. The last question. What was it? Sorry. Last question was which of the IV? Which of the IV? That one is stepwise. You have to do that stepwise. Okay, the last question. You need to do the stepwise. You can't just, you need the data and then you need to do the stepwise regression. I think it's here. Okay, this one, you see, still not showing the last one. This one. You see the last question, which of the IVs are better? You have to do a stepwise to check which one is a better contributor, which of the 4 or 5 variables that we saw just now, which one is the best. Okay. No shortcut. That's a normal way. That's why I say you need a stepwise here. Here you only need the Pearson correlation matrix. Here, of course, means. Whenever this question says level, think about means. Means and the level. Means and the level. Means, from means you determine your level. Level got 3, high, moderate, and low. So you know how to fix it. Then significant relationship, you know how to find the correlation matrix. Okay, but if the question say find out the best predictor, then stepwise. If the question say what is the contribution of each when the other variables are controlled, then it is hierarchical. If they just ask you what is the contribution of a set of variables, one group like that, it's multiple regression analysis. Okay. Okay, not class.
Okay, thank you. Okay, thank you. Okay. We need your video very much.
Okay, sure. Actually, you can communicate with me, but of course, I'm very busy. I got my own students to look after, and my supervisors. Many of them. I got about 16 plus 3 now. Okay, so I need to spend more time with them. I need to answer a lot of their questions. But let's see if there is a chance that we can meet. If you come down to Malaysia, you meet us in person also can. Maybe after all the COVID-19 era of pandemic, if you happen to come to Malaysia, we will meet in person. I will stay.
Look forward.
Yeah, I will stay in Sergi for at least another 2 years. I want to graduate all my students. Then only I want to leave. So all my students must graduate before I leave. That's my what do you call my I won't say ambition. That's my undertaking. That's what I promised myself. I cannot leave halfway. I must make sure they finish. Okay, so I will be here until they finish. At least 2 years. I think I can finish them in 2 years. Okay, so if you happen to come down, we will meet. Okay, we will meet in person. And for being with me all these 7 weeks, from early last month, I think you were with me since July until now, 7 weeks, 7 times 7, 49 hours. You have been consistently listening to me, very patient. That's one thing I like about China students. When you teach them, they are very, very attentive, very, very patient, very disciplined. I really like that features. Because I've taught in Malaysia, I've taught the Malaysians, I've taught even, especially Malaysians, you can't have full attendance or full attention. If there are 20 students, maybe a few won't be listening to you, a few may be doing something else. They won't disturb you directly, but indirectly they will disturb you. That means they keep on telling you that we are not with you, we are not listening to you, things like that, no, from their body language. I don't see all this in my China student because now it's online. But when you all first came last July, first batch, so far I've taught about 5 cohorts, 5 groups of different stages. So the first group, second group, third group, all I think I taught face to face. Even the Michael and his gang who are sitting in with us now, they all were here when I taught them research proposal. Okay, so we were face to face. I always notice they are very obedient, very attentive, and they are the real learners. I would say learners. If you are a learner, you must be very disciplined. You must be, because I'm sitting here, I'm teaching you, I'm doing something for you. Nothing is for me, Whatever I do, it's not for me, it's for you. So if I prepare so much for you, and then you are not responsible enough to take them back to you, to take them as yours, then I can't help you. See, I have done so much work, I've done so much preparation. See, I'm giving every day, I'm preparing a lot of new things. See, my lectures are always different. If you compare my lecture this time with the last semester lectures, they won't be same. They won't be same. But I have a lot of new things coming in because every time I think about something new, I'll bring inside my lecture or discussion. So I keep on changing my slides, keep on changing my PowerPoint, keep on bringing in new issues, new materials. So it's never the same. So that means I'm spending a lot of time on the preparation of notes and all that. So if you don't make full use of it, I think you are the loser. I'm not the loser because I don't lose anything. By doing this, I don't lose anything, but I will be sad. I will be sad in the sense that there's so much of effort from me, but you didn't make use of it. But with the China group students, I don't say that because I know you all are very attentive. You're very good. You are one of my best students, I would say, the China students, all the batches. I've taught all the batches, face-to-face plus the online. I noticed that you people are very obedient. You respect your teacher very much. And therefore, your learning is happening. To me, you learn because you are attentive, you are disciplined, you really bother about your learning, you are very responsible. So all this make you good learners. Okay, that's why when you come here with very little knowledge also, we can really help you. Even though initially it's a big challenge for us, but after some while, when you know that you are learning, we will bring you to the proper track. We can guide you. We can guide you because you are willing to learn. You are willing to learn. Okay, that's a beautiful thing for a learner. We can learn anytime. We can learn every time, every day. But your interest must be there. So as long as you can provide interest, it's very good. Okay, it's very good. So keep being interested. Keep moving. Keep learning. Enjoy your study. Even though you are not here, if there is a chance to come over and see Segi for the new students. Some of you have seen Segi before, but some of you may not have seen Segi University. You come down, you meet us, you talk to us. We will be very willing to do that. Okay, so just wait for the COVID to finish off. After that, we may have an opportunity to meet in person, for face to face. At that time, we can really talk, we can really communicate well. Okay, I think I'm finishing here. Should you have any very difficult questions or something like that, you use my email to communicate with me, but don't expect immediate communication or response back because sometimes I don't see my mail for 1 or 2 days. Okay? So don't expect immediate answer. I will answer, but when I come across, I will answer. I will give you a response, but not immediate answer. If you're lucky, maybe I see it yours sooner, then I answer you sooner. If not, you may have to wait. But you can always communicate. Always communicate with me using my email. My email is kajosa, KAJOHSA @yahoo.com. That is my private mail. The other mail, the Segi mail, will be Satyamurthy Kannan, one word, @segi.edu.my. I think if you type Satyamurthy also, I think probably it will pop up again, because it's okay lah. You will be popping because you don't have many other names like this one. Okay, if nothing, then I would like to say best of luck to you. Keep studying and keep moving. Always learn, study. But make sure you study with, what shall I say, with more understanding. Don't simply read. And don't think that if you read once is enough. Well, reading once is not enough. Read 2 times, 3 times, 4 times, 5 times. Every time you read, you have an improvement in your understanding. Let's say first time you read 50%, second time 60, third time 70, then fourth time 80. So it keeps increasing. Your power of understanding will keep increasing. So never say, oh, I've read. How many times? 1 time. That's not enough. I think I've read many articles, many lessons, many times, you know, sometimes 10 times, 11 times, 12 times. But after that, I'm very clear. I'm clear. So maybe I've got about 90% out of what I read. So that makes me very comfortable. Okay. So don't think that once only you read, that should be enough. It's not enough. Definitely not enough. Okay. So that is my advice for the moment. Should we have a chance and opportunity to meet again, we will meet in person, in face-to-face style. If not, also we can still communicate. Use my email to communicate with me, or use Julia to communicate through her, because she's down here. She can always bring your messages to me. She's down here in Malaysia. Okay. Thank you so much, class. Thank you very much for being so patient.
Thank you.
Thank you, Dr.
Okay.
Thank you very much.
Yes.
And
Sure.
see you in Malaysia.
Okay.
Thank you, sir.
Yeah, sure.
Thank you, Doctor.
Yeah. Thank you.